Okay, so continuation ng ating topic discussion. Okay, part 2 ng ating design of tension members would be shear lag, okay, block shear, and design of cables and rods. Okay, so proceed tayo dito directly on on shear lag. Okay, yung mga problem na na-discuss ko sa inyo from example problem 1 to 3, most of it are tension plates, no? Meaning directly connected yung member mo dun sa connection mo. Okay? But in real life kasi, hindi naman talaga most of the time plates ang ginagamit natin. No? Minsan may iba tayong section na ginagamit na na-discuss natin. Okay? For example, yung mga wide flange, di ba? Wide flange, angles, okay? So on and so forth. Okay? Now, yung shear lag kasi na topic na to, mahalaga nating may discuss to kasi it affects our calculation. Okay? It affects our calculation. So, ano ba yung shear lag na tinatawag? No? And paano ba siya in-estimate? So, yun yung gagawin natin for this session. Okay? So, when a member daw is connected through some of its elements only, shear lag occurs. No? So, yun sa mga case na to. So, halimbawa, dito sa wide flange or double shape na section, bibilangin mo yung elements mo. So you have first element, second, third, fourth, and fifth. So 5 elements ang meron ka sa double shape. Similarly for L shape naman, okay? So you have first and second. So 2 elements lang. Okay? So nangyayari daw yung shear lag usually kapag yung connection mo, only one element is connected, no? So and usually ang pinakamaganda example nito is itong nasa figure as shown. We have an angle wherein yung angle mo is connected to the one leg only. Okay? So, if you would check kasi yung pinaka-stress distribution on your connection, no? If you would cut a section somewhere here on the mid part of your tension member, no? I think on this one we could assume na it's connected on a gasket plate, and we have a welded connection, no? Welded all around nung ating angle. Pag nag-cut ka ng section dun sa mid part, obviously the stress distribution is somehow uniform. Okay? Uniform in distribution. Now, it's a different scenario if we would go near the connection. So you could see here on the stress distribution dito sa may okay? Sa may section cut na to, na yung stresses on mayroon tinatawag na stress lag, no? Stress lagging, or yung stresses dun sa kung saan at these points, no, mataas, and then dito sa bandang gitna na to, and even dun sa member na hindi connected, possibly minimal stresses or possibly zero pa nga no? Zero pa dito on the leg na hindi connected, no? So yan yung itsura ng stress distribution on the connection. Okay? So yun nga, shear lag, ang sabi, would occurs if only a portion of cross-section is connected and connection does not have sufficient length. Okay? So para mas ma-visualize nyo, I think we need to provide more example, no? So ito yung angle, no, shown, pero dito we have a bolted connection, and this was connected only at one leg of that angle. Okay? So yun yung length of connection natin. Nag-apply ka ng load P at one end, obviously. Okay? So, ang assumption natin dito, no, lagi, so consider for example na ito yung magiging rupture lane natin, no, or rupture plane natin. Okay? Dito siya mag-rupture or mag-fracture. We would have the distribution of forces through this section only, no? Itong gray shaded area na yan actually yung diyan ma-distribute yung mga forces, no, onto this section. Okay? So you could see here on this figure na itong section na to would carry yung mga tension forces na in-applied mo. Okay? And then if we would check yung nangyayari dun sa area on that rupture plane, in terms of this shaded area in black, since yun lang yung part ng ating member na nagke-carry ng ating tension member, okay? Yun lang, no? Yun lang talaga yung loaded, itong black area, no? And then itong area in white ng ating kumbaga rupture ating failure plane or failure path natin is hindi siya talaga nagki-carry ng hindi siya effective in tension and hindi siya nagki-carry ng load. Okay. So ito yung tinatawag nating shear lag, no? And it affects our calculations. Okay? It affects our calculations. So to account for its to account for its existence, ang ginagawa natin, we modify our effective net area. Okay? Remember on our problem 1 to 3, we mentioned or we introduced yung parameter na U, no, or the shear lag factor. Okay? So sa ibang book natawag siyang reduction coefficient. Basically ang gamit niya is you could multiply this parameter with the area net and you would have the what we call the effective net area A sub E. Okay? So yun yung ginagamit natin to account for the shear lag. Okay? So let me repeat lang, no. Shear lag happens on specifically for tension members wherein yung tensile load mo daw is transmitted on at the end of the member by connection to some, no, but not all elements. Okay? Yun nga yung example na binigay natin kanina. Okay? So gusto ko lang i-take note, no, na yung equation na to is applicable for bolted connection and welded connection, no? Ang difference lang nila is on how you would calculate yung pinaka net area, no? Net area. Iba kasi yung net area in terms of bolted connections. Obviously, you need to account for the area occupied by the bolt holes and yung area net calculation for welded connections. Ito walang bolt holes. Okay? Sige. So, I think may example tayo niyan, no? Okay? Now, the problem is, paano mo ba siya i-calculate yung shear lag? No? Depende kung ano yung shape na gagamitin mo. No? So, ito si NSCP 2015, nagbigay siya ng table showing all the cases for shear lag determination. Okay? Yung reflected on this PowerPoint is from AISC manual since mas malinaw siya. Kaya yun yung ginamit ko. Okay? But to give you an idea, we have 8 cases, no? And usually may iba't iba siyang scenario. Okay? Siguro mas maganda isa-isahin natin, no, para mas maintindihan natin yung kung paano siya gamitin. Okay? Kasi mahalaga to since sa board exam possibly iba't ibang section yung ibibigay. Okay? Even on your in your examinations. Okay? Sige, so try natin isa-isahin yung ating mga cases, no. Punta tayo sa case 1. Okay? For case 1, as you could see here, ito yung description niya. Okay? Ang description niya is that all tension members where the tension load is transmitted directly to each of cross-sectional elements by bolts, no, or welds. Okay? And then meron siya exception na binabanggit, no. So ibig sabihin pala, kung we would go back again doon sa explanation natin on our example problem 1 and 3, no, we assume na yung shear lag factor natin is 1, di ba? So dito kasi magpo-pull yung case na yon kapag we're using tension plate, no, wherein yun nga, all tension members are directly connected or transmitting the applied load. Matik yun, we have a shear lag factor equals to 1.0. Okay? So ito yung mga cases niya. We have tension plate, all bolted and all welded. Okay? So applicable din siya sa ibang section, guys, no? Halimbawa for wide flange shape, but you need to make sure na lahat ng elements niya is connected, no? Directly connected. Otherwise, hindi applicable tong case 1. Okay, hindi applicable yung case 1. Okay? Sige, so let's proceed on case 2. Okay? For case 2 naman, ito yung description. Okay? Zoom natin. All tension members except plates and hollow structural steel section where the tension load is transmitted to some, okay, but not all of the cross-sectional elements. So by bolts or longitudinal welds, and it was mentioned na alternatively for WMS and HP, case 7 may be used. Okay? So dito naman, ito straightforward din to, no? All tension members, pero yun nga, no? Some, no? Ito yun yung dito no? Keyword dito, some but not all, no, of the elements is connected, no? And sabi niya, you might also want to check case 7. Okay? So yung formula niya on shear lag factor determination is itong formula na U is equal to 1 minus X bar divided by the length, no, L. So siguro for us to give an idea paano na-define yung X bar and L, no, ito yung definition niya. So yung L mo, so punta muna tayo sa L, no, is the connection length measured parallel to the tension load. Okay? For bolts, it is out-to-out distance between extreme bolts. Okay? So, sige, let's proceed on muna, bolted connection. You could see here na yung definition ng L is simply the out-to-out distance, no, between the extreme bolts. Ito kasi yung dalawa, yung extreme bolts natin, no? So, siya yung pinakamalayo. So, kunin mo lang yung center line to center line, that would give you the value of L. Okay? Similarly, on this connection, naka-staggered ka. Okay? So, ito pa rin yung extreme bolts natin. So, that would define our distance L. Now, in terms of weld naman, okay, may dalawang case tayo. Yung unang case is equal yung length ng ating weld. Okay? So, ito daw yung definition ng L. On this case naman, hindi equal yung, meron tayong L1 and L2, no, for our welds. So, ang ginagawa, to calculate yung L for this scenario, kunin mo lang yung average, no, nung two lengths. Okay? Sana malinaw to. Okay? While on the X-bar definition, meron tayong mga figure dito showing, no, yung X-bar na gagamitin natin. So, for example, on wide flange section, we have this, we're in connected, no? Connected yung ating web to a plate, no? To a plate like so. Okay? Ang sabi, you could define yung X-bar as the distance from the center of your web going to the face of your connected plate. Okay? As simple as that. Okay? And then for angle, okay? For angles naman, as shown on this figure, okay? Paano niya dinefine yung X-bar, no? So, ang ginawa niya, from the edge of your, from the surface of connection nung gasket plate and angle, that's the starting point, to the centroid nung nung angle mo, no? That would define your X-bar. Now, in terms of centroid definition, I think everybody knows, no, itong database natin na ginagamit, specifically for angle. Okay, yan yun, no? L. So, meron kang mga list of different section per angle. So, yung centroid na yon, you could determine the centroid using this table, no. So, ito yung pinaka-guide niya, no. Ito yung pinaka-guide ng ating angle na figure. Okay? So, ito yung definition ng X-bar. Okay? Itong distance na to, and ito naman yung Y-bar. Okay? So, if we would look dito sa table, ganun pa din, no. You just need to refer dito. Okay? Halimbawa, for axis XX, ito yung Y-bar, and for axis Y or axis Y, ito yung X-bar. Okay, so on this column ka lang magre-refer. Okay, on this two column ka magre-refer for you to define yung definition or yung location ng centroid for an angle. Okay, so for example, sige, let's quickly check itong 8 by 8 by 3 port. No, this is an equal angle, meaning similar length yung equal length yung leg niya. Okay, so dapat parehas yung value ng Y-bar and X-bar. Okay, so hanap tayo ng unequal angle. Ito yung 8 by 6 by 7 over 8, no? So unequal to, no? Yung length ng leg. So you could see na iba din yung value, no? Iba din yung value. Okay? Sige, so let's go back on the PowerPoint. Ito naman, channel, no? We have a channel section connected to a gasket plate. So yung X-bar mo daw doon is ganun din, from the surface of connection to the centroid ng channel mo. Okay? Similarly for WT, okay? Or sorry, no? Let me correct that. For wide flange daw, wherein yung wide flange mo is connected only on the flanges, no? Top flange and bottom flange, like so, no, bolted connection. Ang sabi, i-treat mo daw siya as WT shape. Okay? I-treat mo siya as WT shape. So, yung area shaded lang yung kukunin mo, no? So, kung ano man yung equivalent WT nung wide flange section na ginamit mo, kunin mo yung counterpart niya na WT, and from that WT section, hanapin mo yung definition ng X-bar. Okay, so similarly, on this figure, ito yung WT natin. Okay, so halimbawa na laman mo na yung equivalent na WT nung wide flange section mo. Okay, so meron dito no? Meron dito on the Y-bar. So ayun yun. Okay, so ito na yun. So dito mo lang siya kukunin. Okay, yung distance na yun. Okay, and usually, meron din tayo ditong pinaka-guide. Ayan. Meron tayong pinaka-guide on how to determine yung centroid. Okay? So, ito yun. Okay? Okay? Itong Y-bar. Okay? So, on this column. Okay? So, okay na tong case 2, no? So, okay na tayo sa case 2. Let's proceed on case 3. For case 3 naman, ito yung description natin. Okay? All tension members where the tension load is transmitted by transverse welds to some but not all of the cross-sectional elements. Okay? So, ganun pa din to. Ang ano lang dito, keyword lang dito is that some but not all cross-sectional element, pero transverse weld yung ginamit. Okay? Automatic shear lag mo daw is a 1.0. Okay? 1.0. So, check natin yung figure. Ayun, so meron tayong transverse weld. No? Kapag sabi natin transverse, perpendicular no, to the applied load. Okay? So, assuming na this is the direction of load. Okay? Straightforward itong 3. Let's proceed on case 4. Okay? So, for case 4 naman, ito yung description. Plates where the tension load is transmitted by longitudinal welds only. Okay? So, plates lang to guys, no? Applicable to plates and longitudinal welds yung connection mo. Okay? So, you can see here na for case 4, meron tayong equations na we need to to check out. Okay? Wherein yung equation na yon, kailangan mo ng distance L and kailangan mo ng distance W. Okay? Now, yung mga distance na yan, as you can see here, yung L pertains to length and yung W is yung distance ng dalawang weld na yan. Okay? If you would fall into this equation, meaning yung shear lag factor mo is 1.0. If nandito ka sa range na to, ito yung shear lag factor mo, and on this range naman is 0.75. Okay? So you need to check at which range ka, no? Nagpo-fall. Okay? Para ma-define mo yung shear lag factor. Okay? So, I think, hindi ko na i-discuss no kasi self-explanatory to, no? Itong case na dalawa for case 4. Okay? So, na-discuss ko na yan. Okay? Let's proceed on case 5. Unfortunately, yung case 5 is something na hindi ko binibigay on the problem, on examination. But, for this one, I would let you do the reading kung paano siya i-define, no? Pero ito yung mga figure na related. Okay? Okay? So, this is applicable for round, kasi, hollow structural section. Okay? I will skip this one. Okay, even tong case 6, rectangular hollow structural section, ito yung mga equations na pwedeng gamitin for shear lag determination. Okay? Okay, ganun pa din, no? 1 minus x bar over L. Pero ito yung mga formula to determine yung x bar. Okay? So ito yung mga figure na related. I would skip this one kasi hindi ko na siya ibibigay, okay, on my exams. Okay? But please be familiar, no? Be familiar. If lalabas siya sa board exam and given naman tong table na to, you could do the problem. Okay. Case 7. For case 7, as discussed dun kay case 2 ata, kung di ako nagkakamali, or case 1. Pwede mo lang i-check to, no? It's case 7 after. So case 2 pala, case 2. So, try natin tong i-check, okay? So si case 7, applicable siya to W, M, S, or HP shape, no? Or T cut from this shape daw. Okay? So 8 shape combination. If U, meron lang siya ditong disclaimer. If U is calculated per case 2, the larger value is permitted to be used. So yun, no? May dalawa kang value, case 2 and case 7. Kung sino yung mas malaking value, siya daw yung gagamitin natin on our calculations. Okay? Then meron siyang dalawang category dito, or dalawang columns. Okay? O dalawang row. Yung unang row is with flange connected with 3 or more fasteners per line in direction of loading. Okay? So ito is bolted connection, 3 or more yung bolts mo. Kapag naman daw, and then connected ka sa flange, no? Linawin ko lang, ito yung dito, keyword, connected ka sa flange. Ito yung mga equation or mga range na kailangan mo i-check. Ito yung corresponding shear lag factor. Similarly, kapag connected ka sa web, okay, ito yung value ng shear lag factor mo. Okay? So, I think ito yung mga example, no? For 7.1, itong row na to. Okay? Ito yun, connected ka sa flange. Okay? Ito yung definition ng B sub F and D, no? Which is a parameter from the wide flange. Okay? While yung sa web, connected ka sa web, ito naman yon. Okay? Ito naman yon. So, ito yung shear lag factor na gagamitan. Okay? And lastly, yung case 8. Okay? Itong case 8, ginagamit ko din, no? On may problems. Ito, very straightforward din to, no? This is for shear, single angle, no? Single angles. If U is calculated as per case 2, the larger value is permitted. So, another notes. So, kapag daw 4 or more bolts per line in direction of loading, automatic yun, it's 0.8. No? And kapag 2 or 3 bolts per line in loading, it's 0.6. Okay? You could see here na bakit kapag madaming bolts, mas mataas ang shear lag factor. No? Pero pag mas kumonti yung bolts mo, lumiliit yung shear lag factor. Ibig sabihin, lumiliit din yung yung area net mo, no? Mas critical siya, no? Lumiliit yung area net mo or yung effective area mo. So, ang reason doon kasi the number of bolts account affects the amount of basically mas marami kasing bolts, mas marami magtutulong-tulong, no, to carry all the loads, or to carry the loads and to transfer, no, from the applied load. kapag konti, mas critical 'yon. Kumbaga yung shear lag mo mas observable doon. Okay? So mas malaki yung nababawas sa area net mo. Okay? So yun yung explanation behind that. Okay? Sige, I think for this one we could do a example problem na to apply yung ating shear lag. But let me first discuss yung types of problem na may encounter nyo on board exam and on my examinations na ibibigay sa inyo. Okay? So ito yung usual na two types of problem na mamimit nyo. Kasi ang kailangan is kapag may problem na binigay sa inyo, alam nyo kaagad i-categorize kung saan ba siya nagpo-fall, no? Para hindi kayo malito. Kasi ang gagawin ng examiner, lilituhin kayo na kung saan lalaruin niya yung given. So kung hindi mo alam kung anong type of problem, hindi ka makapag-solve, no? Or hindi mo ma-solve yung problem. Okay? But sige, let's muna, no? Discuss itong type 1. No? Tinatawag ko siya actually design type ng problem. So sa design type daw, yung loads mo are given. No, loads mo are given and dimensions or sometimes grade of steel should be determined. Okay? So ang case na to is on the discussion of design procedure, no? Na introduction natin, we mentioned na the fundamental rule is that the required strength should always be less than or equal the available strength. Okay? So ang sabi natin, required strength based yan sa loads. Okay? Based sa loads. And yung available strength natin based yan on the material that was supplied, okay, and its properties. Okay? So dito pala parang lumalabas lang kapag design type ka, loads are given. So parang itong left hand side ng equation, given 'yan. Aalamin mo kung ano yung equivalent na niya, no? Na dimensions and possibly grades of steel. While yung isang type which is the investigation type, usually sa board exam ito lang naman yung lumalabas, no? Dimensions are given or yung material properties is given. So ito yon, no? Itong available strength, kasi nga available strength yun, yung mga sizes and material specification. Ang hahanapin mo would be the loads, no? Or the strength, no? Nung given section, okay? So parang baliktad naman yon, okay? Yung given on this one, okay? And meron akong gusto ring i-share, ito yung last third type ng problem na binibigay ko and possibly ibigay sa board exam nyo would be the advocacy type na problem, no? So dito, yung loads and dimensions are given. So ibig sabihin, ito yung loads mo and even yung dimensions ng mga materials mo and material properties, given yon, no? Ang itatanong is adequate ba, no? Or ipapacheck yung adequacy, or yung ibang way to check yung adequacy is yung tinatawag nating demand capacity ratio or DCR, no? So yun yung mga i-define mo, no? Kung safe ba yung given structure mo. Okay? So let me emphasize, no? You need to be aware on how to categorize yung mga types of problem na binibigay sa inyo para ma-solve nyo siya ng tama. Okay? Sige, proceed tayo dito on example problem number 4 and try nating basahin, no? Patulong nga ako sa pagbasa. Siguro okay, patulong magbasa Miss Varlis. Pakibasa yung problem natin, problem number 4. Please.
Hello po, sir. Rinig po ba?
Yes, medyo palakas lang ng boses. Okay.
Determine the likeliest W12 sections that can be used using LRFD for members in group A, B, and C in the bottom chord of the class shown. There are 4 to 16 mm bolts in a section as shown, and it can be assumed that there are 3 rows of bolts as per direction of loading. The service loads is 61 kN and CLL 180 kN is 830/60. Ignore the shear failure.
Okay? And then, yung hinahanap?
A. Determine the actual force on group A. B. Using ASC database, what is the likeliest section for group A? C. What is the corresponding demand capacity ratio based on rupture failure?
Okay, thank you. So, question. Based dito sa problem, anong type of problem tong isosolve natin? Just to make sure that we're on the same page, no? Anong type of problem? Di ba may binigyan akong tatlo? So, anong type of problem tong problem 4?
Advocacy type po kasi nahanap po yung DCR.
Okay, so medyo tama 'yon. Okay, tama 'yon. DC ano to? Advocacy type. Pero actually nakalagay na dito no, design type of problem. Okay? Kasi nga as you can see here, given yung loadings mo, okay? Tapos hahanapan mo daw siya ng lightest or pinakamagana W12 sections na papasa siya, no? Considering all mode of failures na applicable. Okay? So yun, no? So it's a design problem. Then from the section na dinefine mo, nag-include pa siya ng tanong for advocacy, no? Type of problem. Pinapahanap niya yung DCR or the demand capacity ratio. Okay? So sige, let's try to solve this one. Okay? Sana may tutulong in terms of calculation para mabilis tayo. Okay? Okay, number one, we need to calculate daw yung internal force, no? And or actual force on group A. Yung group A members kasi, as you could see, since we're by the way, no? By the way, if we're dealing with trusses kasi, no? With trusses, expected mo na deflection niya somehow similar with no? Similar with beams, okay? It should be on this deflected shape like so. Okay? Like so. So kumbaga kung beam ka, expected na yung deflected shape mo somehow looks like so, okay? And alam mo na rin na yung ano niyan, yung at midpoint yung top fiber niyan would be under compression. Okay? And then yung bottom fiber naman obviously would be under no? Would be under tension, no? So, if we would relate this the same logic on trusses, okay? We could actually conclude na no? On our trusses, yung mga bottom chord mo would be under tension. Okay? Under tension. And yung possibly, yung mga upper chord member mo would be under compression. Okay? Now, itong mga webs, kailangan mo check yan kung tension or compression. So, it varies no? But most likely, as I have discussed, itong bottom chord would be under tension. Okay? So, under, yung tanong dito is, yun nga, i-design natin basically si group A. Okay? So, first step, i-define muna natin yung actual force, no? Na-apply dun sa dun sa group of na yon, member truss na yon. Okay? So internal force, okay, or axial load. Okay, sige, let's try to screenshot pala no yung ating truss structure. So we have this truss configuration wherein by common sense, if we would check yung ating mga distances, we have ano daw, no? We have 4 meters na height, vertical height. And then we have spacing na 3 meters ito, no? So kung 3 meters yan and 4 yan, we have 3-4-5 triangle, no? We have a 3-4-5 triangle. Kung let me repeat, kung 3 meters to, okay, and 4 meters yan, so this one would be 5 meters. Okay? Sige. And then since yung given sa problem, okay, is service load, okay? We understand what service load meaning, no? It means unfactored yung ating load. So yung concentrated load daw na to due to dead load is 61 and yung concentrated load at this location is due to live load naman is 123 kilonewton. Okay? So first step is to to list out yung mga given, okay? So obviously yung ating unfactored loads, okay? Yung ating mga unfactored loads would be no? Yung number 1, yung due to dead load which is 61 kilonewton, okay? And number 2, yung due to live load equals to 123 kilonewton, okay? Now if we want to calculate kasi yung P sub U, okay? 'Di ba? Yung P sub U natin is if we were go back on the LRFD, no? Design procedure, mayroon tayong appropriate load combination. But dito kasi ang given is dead load and live load lang, okay? So matik 'yun. Pagka dead load and live load ang given, ang mag-govern is yung di ba? 1.2 dead load plus 1.6 live load. Okay? So let's try to use that equation to solve yung ating factored loads. By the way, malinaw din sinabi sa problem, LRFD yung gagamitin natin on this problem. Okay? So sige. So ibig sabihin our factored loads, our factored loads. Okay? As per LRFD would be would be 1.2 dead load plus 1.6 live load. Okay? Service load kasi yung given or unfactored loads. So we could calculate na yung value ng ating P sub U. Okay? So we would have the P sub U equals to 1.2 dead load. Okay? Or 1.2 P sub DL plus 1.6 P sub LL. Okay? Now plugging in our values, we would have 1.2. Okay? Dead load is 61. Okay? Plus 1.6 live load is 123. Okay? And we have the value of our P sub U, which is equal to ilan?
270 kilonewton.
Pwede pa ulit?
270 kilonewton.
Okay, 270 kilonewton. Okay? Yan yung load PU acting dun sa on this at this joints. Okay? Now, okay na tayo sa factored loads, na-define na natin siya. If we would look dun sa ating pinaka structure, since yung ating loadings are actually symmetrical, symmetrical yung application ng loadings. Ibig sabihin, yung ating reactions would possibly also also symmetrical. So sabihin natin na dito, i-assume lang natin ito yung sabihin natin reaction vertical, left. Okay? And then ito naman is reaction horizontal, left support, left support. Ito naman sabihin natin, this one is our reaction vertical, right support. Okay? So yan yung magiging natin, direction ng ating reaction. And ang first step pala, by the way, in solving any process problem is to check muna kung determinate ba or indeterminate yung or check the degree of indeterminacy nung given class mo. Yun yung magandang practice kasi if you would try to solve tapos indeterminate naman pala siya, so useless din, so might as well check muna yung degree of indeterminacy. And quick recap lang, quick recap lang tayo pagdating dito sa checking ng degree of indeterminacy for process. Although siguro na-discuss na sa inyo to rin, tapos na kayo dito, kapag planar case or 2D yung process mo, ito yung formula na gagamitin mo for the degree of indeterminacy. Okay? Yung reaction plus yung member minus twice nung joint. Okay? Twice nung joint. Kapag yung values mo is 0, ibig sabihin determinate yung structure mo, stable siya. Okay? Kapag naman yung DI mo is greater than 1, it's indeterminate. Ibig sabihin you could not use the three equations of equilibrium to solve yung thrust problem mo. Okay? And kapag yung degree of indeterminacy mo is less than 1, that means it's unstable. Okay? And the definition for the R is the number of known reaction, M is the members, and J is the joint. So might as well use this equation kasi straightforward siya. Okay? Sige. So this is just for the sake of demonstration, So best practice kasi is to first define yung degree of indeterminacy. So let's try to define, So yung DI mo, okay, would be equals to the reactions, total number of reactions plus total members minus 2 times the number of joints. Okay? And looking on the problem, we have number of reactions, 2 for pin connection and 1 for roller. So meaning we have 3, We have 3. Okay, 3 for R. Okay, plus, okay, yung number of members natin for our trust system, we would have, sa bottom chord muna tayo, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, 23 members minus twice nung joints natin. For the joints, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? 13 joints. So, plugging in. Okay? We would have the value of our DI or degree of indeterminacy, which is equal to ilan?
0 po.
0. Okay. So, this is equal to 0, meaning our conclusion, this is determinate, no? This is determinate. And we could use the equations of equilibrium, no? Yung summation forces vertical, summation forces horizontal, and summation forces, summation moment, okay? And we could possibly use method of joints or method of section. Depende kung ano yung member na pinapahanapan ng reaction, okay? Now, since meron tayong value ng P sub U, na-calculate na natin kanina, okay? Ito yun. Since, and we need to determine the internal force of member A, okay? Ano sa palagay nyo yung mas appropriate na method na dapat natin gamitin? Method of, yung mas mabilis, no? Method of joints ba or method of section? Well, obviously, method of joints kasi andun na siya kagad sa ano eh, no? Sa support eh. Okay? So kunin lang natin yung mga values niyan, we could now use method of joints, okay? Mabilis, okay? Pero kung mas lalayo ka sa support, diba, at this point, and you want a quick internal force, maybe the best option is to use method of section, diba? Kasi ang method of, kung mag-method of joints ka dyan, lahat ng joints from the support, isa-isahin mo yan, so tatagal ka, okay? So the best on that case is method of section, okay? Sige, let's use method of section, but for now, let's try to calculate yung ating mga reaction. Since sa applied thrust system natin, wala namang horizontal load, matik itong RH left, no, would be equal to 0. Okay? And then since symmetrical yung applied loads nga natin, obviously yung reaction would be equal, no? Would be equal. Okay? Sige. So since symmetry yung load natin, so we could say na by symmetry, okay? By symmetry, okay? Yung reactions natin would be vertical, would be equal to the total number of okay? Number of loads na in-apply, and that is 1, 2, 3, 4, 5, no? So 5 times PU, okay, divide 2, okay? 5 PU divided by 2, okay? Divided by 2. So sabihin na lang natin multiplied by 1/2, okay? Okay? So you would have the vertical reaction at our support, okay, which is equal to ilan? I-substitute natin yung values. Right?
175.
675 po.
Okay, sige. Wait lang guys, no. Isulat natin 'to. Okay. Ilan to? 600?
675.
Okay.
675 po.
Okay, sige. Thank you. Now we already have the reaction, okay? Let's draw the since we mentioned na ang mas mabilis na option dito, use method of joints, okay? So if we would use method of joints for joint dun sa support, no? Dun sa support, let's try to draw yung ating free body diagram, okay? Free body diagram. So again, ito yun, no? The free body diagram natin would be this one. We have this member. Tapos meron tayong siguro yung reaction na lang, no? Yung reaction natin na na-calculate natin, okay? Okay, and our reaction, no, as per calculation, is equal to this one, okay? Okay, sige. And then, meron tayong triangle now we could use, no, on our calculation. So for example, no, we could say na based dun sa figure, we have the height as 4, no, itong run as 3, so meaning our hypotenuse would be 5, no? So we have a 3, 4, 5 triangle. Now first equation now we could use, okay, so dito since we're going upward, we could say na on this member is this going downward para may lalaban. In terms of summation force horizontal, since this is going to the left, meaning itong member na to should be going to the right, no, para may magre-resist. Now dito we could say na this is load P, no, or internal force P, and this sabihin natin this is internal force A, no, force at member A. So sige, let's try to use yung unang equation, no, method of joints. Summation forces vertical, okay, will be equal to 0, okay, and then let's say upward positive. So going on our free body diagram, we could say na 675, okay, upward, minus yung P, okay, P na internal force with multiplier, no, multiplier, okay. So ang kailangan kasi natin diyan sa P na yan, yung kanyang vertical component, no, yung vertical component niya, okay. So para makuha yung vertical component niya kapag given ay mga slope, okay, so kunin mo lang yung equivalent ng vertical component, which is 4, okay, for the numerator, then you need to divide by the hypotenuse, okay. Okay, so 4 over 5, okay, so equal to to 0, okay. Now simplify, no, we would have P is equal to ilan?
843.75.
Okay, sige. Siguro ganito na lang, no? Since may value naman kayo diyan, pero ang gagawin ko na lang siguro pag nilipat mo tong P sa kabilang equation, magiging positive. Tapos para makuha mo yung value ng P, i-divide mo, no, yung both equation by by 5 over 4, no? 5 over 4. Sorry. I-multiply mo na lang pala yung both equation by 5 over 4. Okay, para ma-cancel out. Anyway, sige. Ilan yung value nito? Yung P? 800?
0.75.
Paulit? 800?
843.75.
Okay, 0.75. Okay? Now, the next equation would be summation of forces horizontal. Okay? Going to the right as positive. Okay? So, may layo natin to. So, we would have going to the right as positive, we could now have F sub A, positive yan, going to the right. Okay? Minus yung P, no, with a certain component. Again, we need to use the horizontal component, so meaning that is 3 over 5. Okay? 3 over 5. Okay? Equal to to 0. Okay? Now, plugging in yung value ng P na na-calculate natin kanina, we would have P sub A, no, equals to, tapos ilipat ko na yung term na to sa kabilang side ng equation, magiging positive. We would have 843.75 3 over 5. Okay? So meron tayong value ng F sub A, no, or yung internal force ng member A. Okay? Which is ilan to?
506.25.
Okay? So yun, no? We have 506.25. Okay? Kilonewton. Okay? So, yung assumption kasi natin kanina, it's in tension. So, lumalabas na positive ka, meaning exactly, no, as predicted. We're in tension force. Okay? Okay, sige. So, okay na tayo sa item number 1. We already have the actual force on group A. Next item is to use daw yung AIS database and ano daw yung pinakamagana section, specifically W12 section na pwede mong gamitin for group A. Okay? So, yun nga, mag-design na tayo. Hahanapan na natin siya ng possible section. Okay? Sige, so let's proceed, no, on the database. Okay? So, reflecting database, no, specifically in W12. Napunta tayo sa W12. you could see here on W12, medyo lakihan natin. Okay, W12. Pagdating sa W12, ang unang entry is W12 by 14. Okay? W12 by 14. Yan yung unang entry. But hindi natin alam kung papasa siya or hindi. No? Anyways, might as well use the first entry, no, to design, no, para we could have an idea kung papasa siya or hindi. Okay? So gamitin natin to. Kunin natin yung mga parameters. Okay? Sige. For example, area 2684. Okay? By the way, letter B. Okay? Sige, let's try to use yung unang entry, which is W12 by 14. Okay? So meaning, meron tayong mga section properties. Pwedeng pakidictate to. No? Pakidictate sa akin. Okay? Yung area gross, yung mga nakapag-print na ng database, pakibigay sa akin. Area gross, ano yung value natin?
Two six eight four
2684
millimeters.
Okay, millimeters squared. Thank you. Next parameters is yung depth.
302.3 millimeter.
Okay. Similarly, yung width of flange B sub F.
100.8.
100.8. Okay. Yung ating thickness ng web.
5.1 millimeter.
5.1 millimeter. And lastly, yung ating thickness ng flange.
5.7 millimeter.
Okay, now we already have the dimensions. We could now check yung ating napiling section kung papasa siya, no? Papasa siya. Remember, itong internal force na to, ito yung demand, no? Ito yung due to applied load. Okay? Now, we need to check yung capacity or yung strength ng ating section, yung available strength, no, na kaya niyang i-provide. Okay? Since available strength siya, might as well start with the easiest mode of failure, which is yielding failure, no. So, let's check yung yielding failure, yung capacity ng ating section against yielding failure to have a conclusion if ano ba yung strength niya, no? Ano yung value ng strength niya? Mas mataas ba dun sa demand, no? Or mas mababa, okay? So, yun yung first step, no? Sa yielding ka muna mag-check, no? Huwag ka muna mag-rupture kasi mas mahirap yun, no? Sige, yielding failure tayo pagdating sa design ng LRFD. So, might as well use kung ano yung mga na-define natin nakaraan, okay? So, sige, gamitin na natin to para mabilis tayo, okay? Okay, ito yung equation natin, okay? Nominal capacity is equal to AG Fy, okay? And sabi natin for LRFD, the design strength P sub U is equal to P sub T times P sub N. Now, we could expound further, no? I-substitute natin yung value ng P sub N. This would be our equations, okay? Let's try to solve. Meaning our design strength, no, for against yielding is P sub T, which is 0.9 for yielding. Area gross, no? Ayun, na ano natin, no? Na naipakita na natin. Okay? 2684 no millimeter squared. 2684 millimeter squared. 2684. Okay? And similarly, yung value ng ating F sub Y, yung given natin is 836. Okay, 836 meaning F sub Y is 248. No?
248.
Okay, sige. Tama. 248. Okay, divide 1,000. Okay? So, meron tayong value ng P sub U. So, ilan to?
599.0688.
Ulit, 500.0
6
7 na lang, okay? Kilonewton.
7 po.
Okay? Dito pa lang, kumbaga, kung ito yung capacity against shielding nung area na ginamit natin, which is itong 12 by 14, and comparing dun sa applied loads, o yung sa demand, ito yung supply, no? No? Ito yung sinupply natin. And ito yung demand. So, we could say na pagdating sa yielding, no? Pasado ka na agad kasi ito nga yung ano mo no? Ito yung demand mo no? Ito yung kailangan mong i-satisfy, no? Na load. And ito yung sinupply mo in terms of yielding. Okay? So, pasado ka na kaagad. Okay? So, okay tayo dito. So, sa yielding, no? So, this is greater than yung nakalculate natin na F sub A, which is ito. So, we could say na okay yan. Ang problem is pagdating sa pagdating sa rupture. Okay? Pagdating sa rupture, kung that same area is papasa pa rin ba? Okay? By the way, just to give you also an idea, yung ibang mga student, ang ginagawa nila is check nila in terms of area, no? In terms of area. Whatever the case would be, parehas lang, hindi naman tama 'yon, no? What do I mean by that, no? Halimbawa, pagdating dito, okay? Ano ba yung required area to satisfy itong load na 'yan? Kaya ang ginagawa nila is they would use the same formula, itong same formula na to, okay? Yung same formula na 'yan. Okay? And they would for them to have a conclusion, okay? So gagawin nila ngayon, okay, is they would use yung value ng 500.25 yung load na yan kasi di ba sabi natin that is this is due to load, applied load, di ba? Yung kabilang side ng equation natin, this is the required strength, no, which is based on the loads, okay? So ganoon ang ginagawa nila, no? Pina-plug in nila yung load. Tapos ang ginagawa nila, itong AG ang ginagawa nilang unknown, okay? Kumbaga ano yung area required against yielding to resist yung applied loads na to. Okay? Yan yung ginagawa ng ibang student, which is wala namang issue diyan. Okay? Kasi ganun din naman yung mangyayari. Ko-compare mo din to with other properties. Okay? So pakibigay nga sa akin yung area gross nito. Pakibigay yung area gross nito.
2,268.
2,000?
268.
268.
145. 16.
145?
16.
16. Okay? Now, as I mentioned, ito yung ginagawa ng iba, no? Ganito yung comparison nila. Kumbaga, ito yung area required by this load, no? Against yielding. Now, i-compare mo to, okay? Common sense, kung pipili ka dapat ng section, okay? Kung pipili ka dapat ng section, dapat, no, yun pala yung first step natin na mas maganda pala yung ganitong option. Kung pipili ka ng section, yung area na isusupply mo dito, okay, para hindi ka na mag-calculate, mas malaki dapat. No? Halimbawa, pagdating sa database, ang kailangan natin is, let me repeat, no, 2,268 na area. Okay? Okay? Para for this load. So, parang ganun pala yung logic, no? Pagdating sa database, ano ba yung area na mas mataas sa 2,200? So, ito, lumalabas na yung W12 by 14. Mas mataas siya. Kaya ito na agad yung unang pinik natin. Okay? Ang problem is, pagdating sa rupture, babagsak ba siya? Okay? So, halimbawa, for W12, pwede rin naman. Okay? Mas mataas siya. Okay? But the problem is, baka over-design na siya, no? Pagka ito yung ginamit nating area. Okay? So, might as well start from the first, for the first section na binigay, okay? So, yung pala yung advantages nung strategy na ganun, na una is, i-ano mo muna, no? I-check mo muna yung area required to resist itong ano na to, no? Itong load na yan, okay? Okay? And then, from that, look at the database and check mo tong yung mga area, okay? So, in this case, try mo yung yung W12. Okay? Kasi nga, mas mataas to. This is greater than this area. Okay? So parang ganun yung logic. And then alam mo na kaagad na sa yielding, mas pasado ka, no? Pasado ka. Okay? Sige. So, and then we also prove na mas mataas siya, okay? Using checking yung yielding failure no? Common sense na yan. So we could now check yung other mode of failure, which is yung rupture, no? Rupture. So check natin yung rupture kung that same section is ano pa din, no? Passing pa din, okay? Okay, let's investigate yung ating given cross section. Okay. So we would use a W section connected yung sa top and bottom flange. We could say na ano, no? Since yung flange lang yung connected and yung web is not, shear lag is applicable, no? Shear lag is applicable. Then ito yung mga given, no? Meron ka daw 3 bolts, no? As shown. So parang in line with the direction applied load and 200 mm daw tong distance na to. Okay? Sige. So going back dun sa formula ng ating rupture, okay? The nominal capacity is equal to A sub E times F sub U, and P sub U is equal to P sub T times P sub N. I-plug in natin yung values dito, no? Nung P sub N, ito yung magiging final equation natin. Okay? So recap na lang yan. Okay? So sige, try natin tong i-copy para hindi tayo paulit-ulit. Okay? So for rupture failure, okay? This is our equations. Okay? Unfortunately, yung FU, ma-define na natin, yung A sub E, wala pa. Okay? Yung A sub E is also equal to, as we have mentioned, the shear lag factor, okay, times the area net. Okay? Shear lag factor and the area net. Diba? So we could expound it further. Okay? So yung maging equation natin would be from this one, would be P sub T times the shear lag factor area net times F sub U. Okay? So ito yung magiging final equation natin for rupture check. Okay? Sige. So yung shear lag factor wala pa tayo. Okay? Area net wala pa rin tayo. Okay? So ito yung mga kailangan natin i-define now. Okay? Unahin siguro natin, no, as usual, yung ating area net. Okay? Now, in terms of calculation ng area net, alam naman natin yon. Okay? Meron tayong dalawang formula doon. Pero ang usual kasi na applicable natin, okay, for this one, no, is ito, no, ito. Okay, let me have the area net. This one is not applicable kasi this is 4 plates, di ba? This is 4 plates. Pero may isa pa tayong formula na pwedeng gamitin. Ano ba yung formula na yun? Yun yung generic formula, no? Na ang sabi, the net area is equal to area gross minus area ng holes, no? Area ng holes. I think na-present ko siya on first problem. Yeah, this one, okay? The net area, okay, is equal to area gross minus area of holes. Okay? Might as well might as well copy itong mga to kasi parang mauulit lang. Okay? So might as well copy. Okay? So sige. First step, define natin daw yung ating nominal hole diameter. Okay? Nominal hole diameter. Okay? Diameter of bolt. Okay? Ano ba yung given na diameter of bolt? The diameter of bolt as per problem is 16 mm. Okay? 16 mm. And sa problem kasi, wala siyang binigay na hole kung standard ba or oversize. So, sabi natin, walang given, assume standard. Okay? So, 16 mm ang diameter ng bolts, tapos standard. Okay? So, 16 mm ang diameter of bolt. Okay? Nominal hole diameter, D sub H, no? Corresponding dun sa table. So, ito yung table natin. Ayun, parehas pala. So, might as well copy this. Okay? For 16, it's, standard, it's 18 mm. Okay? So, meaning, This is 18, no? This is 18. So we would have a tolerance of 2, no? 2 millimeter. Okay? 2 millimeter. Now, going back on the equation, design hole diameter is equal to the diameter of bolts, okay, which is 16. Okay? Plus yung tolerance, okay, which is 2 millimeter, plus 2 millimeter for the damage portion. Okay? We would have our final design hole diameter equal to 20 millimeter. Okay? So, meron na tayong diameter of hole, we could now calculate yung ating net area. Okay? Net area is area gross minus area of holes. Okay? So, yung formula natin, isang formula natin for area net is, di ba, yung net width times thickness of plate. Hindi na applicable yun dito kasi hindi naman to tension plates, no? This we're talking about we're talking about wide flange, no? And going back dun sa wide flange, no, if we would look into the given section, no, ipakita lang natin yung ating section for the sake of demonstration. No? Ganito yung itsura no? Ganito yung itsura ng ating no? Section. So din so for example, ito yung flange natin, okay? So ito yung mga bolt holes natin, di ba? Ito yung mga bolt holes natin. And yung kailangan nating area, no, net area would come from this shaded area na to. Okay? Ito yung included sa net area. No? Mag-resist ng applied load. Okay, yun yung description ng ating net area. Now, the thing is, meron na tayong na-define na diameter of hole. And diameter of hole natin, andito andito sa flange. No? Design diameter of hole. Okay? So, let's calculate now, no, yung ating area gross. Okay? Ito, straightforward lang naman to. Okay? Straightforward to. In a way na you just need to refer dito. Okay? Area gross ng ating given section na ginamit natin. Okay? We're using 12 by 14. Which is ito, 2684. No? 2684 yung area gross natin. Okay? Okay? Minus yung area ng ating holes. Okay? Now, yung area ng ating holes, as you can see here, meron rectangular section lang siya. So, ito yung pinaka-width niya, yung diameter of hole natin. And yung pinaka-height niya is common sense din to. No? Itong dimension na to. Okay? And this dimension, no, alam natin yan, this is the thickness of our flange. Okay? Thickness of our flange. Times 4, no? Times 4 kasi apat yung butas, okay? So, we could have the diameter of hole 20. Okay, 20 times yung ating thickness of flange, no? Yan yung pinaka-height niya. Binigay natin yung ginamit natin kanina, 5.7, no? 5.7 millimeters. 5.7, okay? And then we have 4 number of of holes, okay? 4 number of holes. So, we would have our area net. So, ilan yun? Ilan tong area net natin?
2,200.
2,000?
228.
2,228.
28.
Exacto to?
Opo.
Okay, sige. So, meron tayong area net. Yung shear lag factor na lang yung kulang, no? On our equation. Yeah, I think we could calculate na yung ating shear lag factor. Okay? Let's go back dun sa mga cases to confirm saan tayo magpo-pull, no? Saan tayo magpo-pull na case. Okay? So, mabilisan lang to. Okay, case 1. Sige, ganito gagawin natin. Isa-isahin natin siya, no? Sige, case 1. Applicable or hindi? Applicable, yes or no? Obviously, hindi, no? Kasi dapat lahat ng elements is connected. Okay? Case 2. All tension members, no? Okay, applicable pa din. Okay? Tama ba? Except plates where tension load is transmitted to some by longitudinal welds, no? So, welds to. So, hindi siya applicable. Tama ba? Pero, sinabi din dito na bolted connection or welds. So, applicable si case 2, no? And ito yung formula natin. Okay? Sige, let's use this formula, no, for shear lag calculation. So, Go back tayo doon. Okay? So therefore, no, for shear lag, no, calculation, okay? Let's investigate case case 2, no? As per case 2. Okay? As per case 2, we could use the equation u is equal to 1 minus x bar over L. Okay? Over L. Sige. So let's go back dun sa figure. Okay? Ano ba yung definition ng x? Ano ba yung definition ng L? Again, yung L is out distance, no? No extreme bolts, and going back on the problem, no? On going back on the problem, we could say na yung L, no? Kung out distance ng ating bolts is itong distance 200, no? So L is equal to 200. Okay? Okay? So therefore L is equal to 200, while yung x bar, no, as defined dun sa PowerPoint natin, is based on this given mga figures, no. Ang tumutugma sa atin as per this figure is ito, no, itong isa na to. Okay, okay, x bar. Okay, for this figure, yung applicable natin as shown on the figure is ito. Okay, we need to treat as WT yung given W section. Okay, so kung WT siya, so sige, pakita natin, no. Actually, medyo mahirap tong given problem na to, no. I-treat mo daw siya as WT. So meaning, hanapin mo yung equivalent, ano niya, equivalent section niya as WT. Okay? Now, yung strategy kasi on how to define yung equivalent WT niya is, una, punta ka dun sa sa given section. So, ang sabi dito, W12 by 14. Okay? So, yung equivalent niyan, just to give you an idea, i-divide mo lang yan by 2. Okay? So, ibig sabihin, WT 6 by 7. Okay? WT 6 by 7. And check natin mamaya kung tumutugma ba yung assumption natin, no? WT 6 by 7. Eh, dapat kalahati lang din ng depth or kalahati lang din ng area. Kasi kinalahati mo yung di ba? Yung given section. 6 by 7. 6 by 7. Okay, ito. Okay. 6 by 7. Ipakita, reflect natin yung yung mga parameters niya, no? Okay, 6 by 7. Okay, double check natin, no? Yung sa W, ang given area 2684, no? Tapos yung sa WT dapat kalahati. Ayun, 1342. Tama ba, kalahati ba to? I-confirm. 2684 divide 2 should be 1342.
Yes po, tama po.
Okay, sige. And therefore, yung equivalent x bar niya, no? Equivalent x bar niya is itong given dito na y bar. Ayan. So lumalabas na yung x bar niya is 44.7. Okay? 44.7. 44.7. Okay, yan yun, no? Yung y bar, di ba? Galing dito, okay? So, sige. Ang equivalent WT natin, no, is WT 6 by 7, no? I-take note na lang natin, no? Equivalent niya? Equivalent WT section. And based dito, that is equal to x bar is equal to y bar, which is equivalent to as 44.7, no? 44.7. Okay? Millimeter. Okay, now you already have the parameters. We could now plug in on our equation. So we could say na at case 2, we could say na u is equal to 1 minus yung ating x bar na 200 divided by baliktad, no? Baliktad pala. X bar is 44.7. Okay, divided by the value of L, which is 200. Okay, so meron tayong value ng shear lag factor. Ilan to?
0.7765.
77
65.
65. Okay? Sige, okay na tayo sa case 2. Let's have a quick review ng ating presentation kung meron pang applicable. Case 3. So obviously hindi kasi ito yung itsura ng case 3. Okay? Case 4, hindi din kasi longy weld yan, no? And plates. 5 and 6 hindi. Okay? Skip. 7 WMS or HP. Okay? Applicable, no? I-check din natin to. Okay? Kasi baka pwedeng mas ano siya, meron siyang value. Okay? So ayan, sabi dito, i-check mo daw ba kung saan ka connected. Kung plunge ka, itong row na to, kung web ito naman. Okay? So plunge tayo. So we need to check yung values ng ating B sub F and D. And we need to check saang range tayo magpo-poll. Okay? So meron tayong dalawang range. Okay? So sige, let's investigate itong case 7 and let's try to copy para hindi na natin dadalhin doon. Okay? O hindi na tayo pupunta. Okay? Sige. Okay, for case 7, we have we need to check the two sets of range and we need to confirm saan tayo nagpo-poll. Okay? So ito yung natin, case 7 natin. So again, i-define natin yung B sub F and yung depth ng ating given wild plunge. Fortunately, meron na tayo, no? Yung ating B sub F tsaka depth. Okay? So ito yun no? Ito yun yung ginamit natin. So, okay na to. Nakalist na siya. Okay? Aha. So, nangyari doon? Okay? Paki-confirm if audible pa rin ako kasi medyo unstable yung internet ko. Hello?
Yes po.
Okay. Sige. Meron tayong value ng B sub F and depth. No, ikukunin lang daw natin yung yung range na yan. Okay? So ang pinakamabilis diyan, okay, ilista mo yung ilista mo yung equation. Ito muna, B sub F is greater than or equal to third D. No? So yun ang pinakamabilis, no. So first natin, range natin, B sub F is greater than or equal to 2/3, no? 2/3 D daw ang sabi. Okay? Yan yung pinakamabilis na strategy. Okay? Ano yun? Okay, ito yun, no. Okay. Now, let's try to simplify yung equation natin. Obviously, if we would divide this by D, kailangan mo rin i-divide by D yung kabilang equation. Okay? Now, since divide mo yan by D, obviously, ang mangyayari is maka-cancel out, no? Yung value ng D dun sa right-hand side. Okay? So, maka-cancel out. So, we could say na pag kinuha pala natin yung range na to, yung B sub F over D, ang dapat greater than or equal to third, no? Kapag nasatisfy yan, pasok ka sa range na to. So, i-plug in natin yung values, no? So, we would have 100 for the B sub F. Okay? Divided by D, the depth of our section, cross-section. Okay? Should be greater than or equal to 2/3, no? Sige, paki-calculate to. Okay, ano to?
0.4.
Ilan to?
0.33.
36. Tama ba?
3,344. 33 po.
0.33, sir.
Okay, sige. Hindi na, to decimal lang yan kasi range lang naman to, no? So this should be greater than or equal to third. Now, to third, alam niyo na to, no? This is 0.67. Okay? This is 0.67. Now, on this case, alam natin na yung argument is negative, no? Hindi okay yung argument. So meaning hindi sa equation na to. We need to check yung next equation or yung next range, which is B sub F is less than 2/3 D. Okay? So less than 2/3 D naman daw. So okay, so gawin natin ngayon is copy natin to. Okay? Copy natin yan and this should be less than. Okay? Less than. Okay? Less than and less than. Now, common sense to na wala na tayong babaguhin. 0.33 is less than 0.67. Okay? So meaning, itong equation na to, yung na-validate natin, dun siya dun siya magpo-poll. So ibig sabihin, ang conclusion natin, yung shear log factor natin is 0.85, no? So therefore, our shear log factor, no? Our shear log factor for case 3, no, is equal to 0.85. Okay? 0.85. Now, ang rule is check mo yung dalawang value ng shear log factor and then kung sino yung pinakamataas, siya yung mag-govern, no? Yung sa case 2, okay? Sa case 2 natin is 0.77, okay? Ito is 0.85. So, this one, obviously, okay, governs, okay? Now, we already have all the parameters on our given equation for capacity, design strength, no, ng ating by rupture. Okay, ito 'yon. So might as well plug in. Okay? Sige. P sub T for rupture. Ano yung value natin?
0.75.
0.75. Okay? Multiplied by the shear log factor na nag-burn. That is 0.85. Okay? Multiplied by the area net, no, ng ating given section. And na-calculate na natin yon. That is 2,228. Okay? And lastly, yung ating F sub U. Okay? Our F sub U for 836 steel is 400. No? 400. So we would have our P sub U equal to
568.14.
Sige, sandali lang 500
68.14.
68 point
14.
14. Okay? Now, we need to formulate a conclusion based dito sa capacity ng ating against rupture. Okay? Yung capacity or yung demand natin, no, na load is equal to 506.25 kilonewton. Okay? So ano yung masabi natin? Safe ba tayo sa rupture or unsafe? Well, obviously this is good, no? This is safe. Kasi mas mataas nga yung capacity natin against against the demand, no? Or the internal force. Okay? So ibig sabihin this is good. Okay? 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 Check natin yung nangyari sa yielding kanina. Ayun, no, compare natin yung capacity ng yielding. Okay din naman tayo doon. Pasado rin tayo sa rupture. Okay? So yung pinaka final conclusion natin, we could say na therefore use W12 by 14. Okay? For group A. Okay? So yun yung pinaka overall conclusion natin for item B. Okay? And lastly, okay? Yung last item is ano daw yung DCR, no, against rupture failure. Okay? Yung demand capacity ratio na tinatawag. Okay? So parang additional na lang yan. Question na lang yan. Pero yung problem talaga na to, this is a design type ng problem. Okay? So sige. For item C, we need to calculate the demand capacity ratio, okay, against rupture. Okay? The demand okay? So yung DCR, no, from the term itself, no, it's a ratio, no? It's a ratio. So this is equal to no? This is simply equal to the demand, no? Over supply, no? Or yung supply or yung capacity. Sabihin na lang natin, no? Supply ito, no? Or yung or yung capacity. Or yung strike na din, no? Based dun sa given section, okay? So yung demand mo, obviously, ito yung due to load, no? Para mas nagkakaintindihan tayo, ito yung due to load. Tapos ito naman yung sa supply, ito yung given section. Okay? Yung strength based on sa given section. And ang pinapahanap is yung sa rupture. Okay? Yung sa rupture against rupture. So, meaning, in terms of the load, we could say na our DCR value, no, is equal to, okay? Yung numerator muna tayo, yung due to load or yung demand, no? That is 506.25, okay, internal force ng ating member, okay, divided by yung ating capacity ng section against rupture, no? Ito yung capacity against rupture, okay? Okay, so we would have a certain ratio, okay? Okay, so ilan to?
0.891065.
Okay, sige. Siguro ibigay mo na lang yung 2 decimal kasi final answer na. Ano?
0.96.
Point Point ilan?
90.
0.90. Okay, so I'm guessing na parehas yung nakuha ng ibang ano, no? Okay, so sige. So okay to guys, no? Okay yung ating DCR. Okay? Ang explanation dito, in terms of the DCR, okay, just to give you an idea, kapag yung DCR mo ay lumampas na ng 1, okay? Greater than 1 ka na, ibig sabihin, fail ka na, no? Bakit? Kasi di ba yung numerator mo, yan yung load mo eh. Tapos ito yung capacity ng section mo. Ibig sabihin, pag lumampas ka ng 1, malaki na yung numerator mo. No? Lumamang na yung due to load. So, critical na yun, babagsak na yung structure mo. Okay? So, pag greater than 1, failed na. Okay? Ngayon, siguro magtatanong kayo, ano ba yung usual na or desirable na demand capacity ratio? Okay? So, ito, mga tips na to on design. No? Actually, in terms of the DCR, ako preferably, no? Ang sagot kasi doon, actually, is depende sa ano mo, sa confidence level mo, no? Pero ako, as a designer, ang rule of thumb ko, no, is I would play my DCR on this ranges, on this range, no, from 0.85 to 0.95. Okay, diyan ko nilalaro yung aking DCR. Okay? Kapag kasi masyadong mababa na, like, halimbawa, 0.5 yung DCR mo, medyo sobrang ano ka na no, sobrang kumbaga over-design ka na, and hindi mo talaga nagamit yung ano mo, hindi na economical yung design mo. Okay? Hindi na economical. So, might as well use 0.85 to 0.95. Okay? Huwag mo isasagad to ano, to siguro 0.9 pwede pa, no? Or yeah, huwag mo isasagad hanggang 1. Okay? Kasi kung may mali ka sa calculations mo, okay? Sabihin natin mas mataas dapat yung load, babagsak pala yung section mo. Okay? Okay? So yun yung ano, yun yung mga strategy. Okay? Sige. So sana malinaw to, no, yung problem number 4 natin, yung pinaka takeaway talaga natin dito, yung calculation ng design type of problem and kung paano mag-calculate ng shear lag, no? Shear lag ng ating given cross section. So dito, we emphasize na kailangan mong i-check lahat ng cases. Nag-fall tayo sa case 2 and case 7, okay? And we also calculate yung demand capacity ratio.